Hello students, this is Dilip Udhani, Assistant Professor at LG Institute of Engineering and Technology. In the last lecture, we have discussed case number 2 when x is sine of ax plus b or cosine of ax plus b. In this lecture, we will discuss case number 3 when x is x raised to m. So in that case, how we will find out pi. So let's start. The formula of pi is 1 over function of dx and x is x raised to m. So in this case what we will do, we will make the function of 1 plus function of d from this f of d, right? And this x raised to m will be as it is. Then after you have to write down 1 over 1 plus function of d as 1 plus function of d the whole raised to minus 1. And then after you have to expand that formula using this concept 1 over 1 plus x, it will become 1 plus x the whole raised to minus 1. So the formula for 1 plus x the whole raised to minus 1 is 1 minus x plus x square minus dash dash dash, and the formula of 1 over 1 minus x the whole raised to 1, so it will become 1 minus x the whole raised to minus 1, and that is 1 plus x square and so on. Okay, so we will apply this formula or this formula on function x raised to m. Okay, so let's start examples. Example number 1, we have to solve this differential equation y double dash plus 2y dash plus 3y equals to 2x square. Write down y double dash as d square y by dx square plus 2y dash is nothing but dy by dx plus 3y equals to 2x square. Now replacing d by dx by the operator capital D, so we will be having d square plus 2d plus 3y, that is equals to 2x square. Now this differential equation is of the form f of dy equals to x. So its solution will be given by y equals to cf plus pi, where cf is a complementary function and pi is a particular integral. So first of all we will find out cf. Okay, so to find cf we have to write down an auxiliary equation, right? And auxiliary equation will be given by equating the function of d to 0. Here function of d is d square plus 2d plus 3 equals to 0. Now we cannot factorize this equation, right? Because we don't have two numbers such that their product is 3 and their addition is 2. So we have to solve this quadratic equation by quadratic formula, right? And that solution is minus b plus minus square root of b square minus 4ac divided by 2. So in this case the value of a is 1, the value of b is 2, and the value of c is 3. So this is minus b and the value of b is 2 plus minus square root of b square, and 2 square is 4. Then after minus 4ac, the value of a is 1 and c is 3. Now multiply 1 and 3 by 4, so it will become 12, and divided by 2a, and the value of a is 1. So this minus 2 will be as it is, plus minus, and 4 minus 12 is minus 8, and divided by 2. Now you can write down minus 8 as 8i square, and square root of 8, it will become 2 root 2, and square root of I square will become I. So taking 2 common from the numerator, so it will become 2 into bracket minus 1 plus minus root 2i and divided by 2. So 2 will cancel out. So final the value of d will be minus 1 plus minus root 2i. Here we are getting complex number where real part is minus 1 and an imaginary part is root 2. So in that case, CF will be e raised to minus 1x into cosine of root 2x, and the next function will be e raised to minus 1x into sine root 2x, and then after writing it in linear combination form, it means you have to multiply first function by c1 and second function by c2, and then after you have to add the result and take e raised to minus 1x common. So CF will be e raised to minus 1x into bracket c1 cos root 2x plus c2 sine root 2x. Okay, now we will find out pi. Okay, and the formula of pi is 1 over function of d into x, and x is 2x square, right? Okay, that is this one, right? Now here we are in case number 3. So what we have to do, first of all, we have to make the function of 1 plus phi of d, right, from this function. So for that purpose, what you have to do, you have to divide this quadratic equation by the constant value. If the constant value will be absent, then you have to divide the given equation by the least power of d. Okay, so from that you will get 1 plus phi d. Okay, so taking 3 common, so 3 by 3 is 1 plus d square plus 2d by 3 into x square. Okay, so 2 by 3. Now this is 1 over 1 plus x, so writing 1 over 1 plus x as 1 plus x the whole raised to minus 1, and applying the formula of 1 plus x the whole raised to minus 1. Okay, that is this one, 1 minus x plus x square and so on. So it will be 1 minus x, this is the value of x, d square plus 2d by 3, plus this is x, so it's a square. Okay, so we have d square plus 2d by 3 square minus so on, and here you have to write down x square. Okay, now we will apply this whole operator on x square. So this 2 by 3 will be as it is. Then after, before applying this operator, we will just simplify this result. 1 will be as it is, d square plus 2d by 3 will be as it is, and then after we will apply the formula of a plus b the whole square, so it will become a square plus 2ab plus b square, so d square will become d raised to 4. Then after d square into 2d into 2, it will become 4d cube. Okay, right? Then after 2d square, so you will get 4d square, and divide by 3 square, answer is 9. Okay, and here is x square. Okay, right? Now if we will just apply this operator on x square, so 1 into x square, result is x square, and then after minus 1 over 3, d square of x square means double derivative of x square, so it will be 2, because single derivative of x square is 2x, and again this differentiation, that will be 2. Then after 2d of x square, so 2d of x square, so it will become 2x. Okay, and after plus 1 over 9. Okay, right? So d4 of x square, it will become 0, d cube of x square, it will become 0, and 4d square of x square, so d square of x square, that is double derivative of x square, result is 2, and this 4 will be as it is. Okay, now we have to simplify this result only. This is x square, then after minus 2 by 3, 2 2s are 4, so it will become minus 4x by 3, and plus 2 4s are 8, 8 by 9. Now we have to simplify this result only by taking LCM. Okay, so we will get final this result, so this is pi, and at last you have to write down y equals to cf plus pi. Done? Okay, right? And you can see that cf is e raised to minus x into bracket c1 cos root 2x plus c2 sine root 2x. Okay, so this is cf, and pi is 2 by 3 into bracket x square minus 4x by 3 plus 2 by 9, right? So this is the general solution of this differential equation, that is y double dash plus 2y dash plus 3y equals to 2x square, right? In the right hand side, it is not necessarily that you will be giving only the function like x raised to m. Okay, see, if you have been given x cube plus 7x square plus 8x plus 9, so in that case also you have to apply this same concept, right? And you have to remember these two formulas, okay, right? So what we have discussed today, we have discussed case number 3, when x is x raised to m. Okay, so when x is x raised to m, so you have to write down function of d as 1 plus phi of d. How will you make 1 plus phi of d, right? From this example you can understand what you have to do. You have to take the constant value common if the constant value is present in the function of d. If the constant value is absent in the function of d, then you have to take least power of d common. So then after it will become 1 plus phi of d. Okay. Then after you have to write down 1 over 1 plus phi of d as 1 plus phi of d the whole raised to minus 1, right? Okay, and then after you have to remember these two formulas, that is 1 plus x the whole raised to minus 1 will be 1 minus x plus x square and so on, and 1 over 1 minus x, write it as 1 minus x the whole raised to minus 1, so it will become 1 plus x square and so on. Okay, then after you have to expand 1 plus phi of d according to these formulas, and you have to apply this operator on the function given to you. Okay, right? So this is the required solution for the given differential equation. So this was all about case number 3. In the next lecture we will discuss case number 4. Okay, thank you for watching this video.